Good morning. Can you hear?
Yes, sir.
Okay. 46 Jan, you can start. I think in the previous class we were discussing Poisson distributions and completed 2 or 3 problems. I don't know which is the last problem we discussed. Is the second one over?
Yes, sir.
Second
Yes,
is
sir.
over. Then we start with this third one. In a certain factory turning out razor blades, there is a small probability of 1 by 500 for any blade to be defective. Clearly, there are 2 possibilities. The product may be a defective product. The product may not be a defective product. Therefore, only there are 2 possibilities. The blades are supplied in packets of 10. Use Poisson distribution to calculate the approximate number of packets containing no defective blades, 1 defective blade, 2 defective blades in a consignment of 10,000 packets. First, we shall construct the probability function with respect to each packet, and each packet contains 10 blades. That's right. First statement. In a certain factory turning out razor blades, there is a small probability of 1 by 500 for any blade to be defective. That means P is equal to 1 divided by 500. The blades are supplied in packets of 10. That means N is equal to 10. N is equal to 10, and 1 by 500 means 0.002. When compared to this 10, 0.002 is a very small number, and there are only 2 possibilities, and N is large when compared to this probability of success. What is success? Getting a defective blade is my success. When compared to this success, N is very large. Therefore, Poisson distribution is appropriate here. Let's construct the probability function, which is given by P of x is equal to m power x into e power minus m divided by x factorial. And we know that m is equal to mu, right? And mu is given by n into p. We have both n and p. Substitute. N is equal to 10 and p is equal to 0.002. Probability of success P. Therefore, 10 into 0.002 is 0.02. M is equal to 0.02. We can easily construct probability function. P of x is equal to m power x. M is 0.02 whole power x into e power minus m, that is e power minus into 0.02 whole divided by x factorial. This is what we call probability function, and this is the probability function with respect to each packet. Each packet. How many such packets are there? 10,000 packets are there. You can multiply this probability function by 10,000 here only, or you can find the probability corresponding to each packet and then multiply by 10,000. In either ways, you can do this. This is the probability function. I multiply because there are 10,000 such packets are there. Multiply both sides by 10,000. You can multiply at this stage only, or you find the probabilities and then you can multiply. In either ways, you can do that. 10,000 into P of x is equal to 10,000 into P of x is 0.02 whole power x into e power minus m is minus 0.02 divided by x factorial. Let's denote this 10,000 P of x by f of x. Therefore, f of x is equal to 10,000 into 0.02 whole power x into e power minus m is e power minus 0.02 whole divided by x factorial. And what is x here? X denote the number of defective blades in each packet. X denote the number of defective blades in the packet. Now let's consider this first case. No defective blade. No defective blade means f of 0. Here x denotes the number of defective blades. And there is no defective blade means x must be 0. Put x is equal to 0 and simplify here. Put x is equal to 0. Any finite quantity power 0 is 1. Therefore 0.02 whole power 1 is 0 is 1. And 1 factorial is 1. 0 factorial is also 1. Calculate. What's the answer? (10,000) into 0.02 whole power 0 is 1. E power minus 0.02 divided by 0 factorial is 1. You just multiply these two.
9,802.
9,802, right? That must be correct answer. If you ಬೇಕಾದರೂ ಮಾಡಬಹುದು ಅಥವಾ you calculate P of 0 and multiply that P of 0 with 10,000. That can also be done. In either ways you can do that. I multiplied here only by 10,000. You ಬೇಡ ಅಂದ್ರೆ you just calculate P of 0 and then multiply the resultant with this 10,000. This is first case. Next is second case. What is second case? One defective blade. That means P of 1. Put x is equal to 1, simplify. 10,000 into 0.02 whole power 1 into e power minus 0.02 divided by 1 factorial is 1. Ten-
196.
196. Exact 196, huh?
196.03.
Okay. That can be approximated to 196. There are 196 packets in a consignment of 10,000 packets in which one blade is defective. Next, third case. Two defective blades. Two defective blades means P of 2. Put x is equal to 2. 10,000 into 0.02 whole power 2 into e power minus 0.02 divided by 2 factorial. 2 factorial is 2.
1.960.
1 point, is that correct? 1.960.
Yes, sir.
This is approximately 2 packets because the outcome is the number of packets. It cannot take a fractional value. So approximately 1.9 can be approximated to 2 packets. Is this clear?
Yes, sir.
9,802, 196, and 2. Next one. This is a question paper problem. The number of accidents in a year to taxi drivers in a city follows a Poisson distribution with mean. That means m is equal to 3. And distribution is Poisson, it is specified. The number of accidents in a year to taxi drivers in a city follows a Poisson distribution. It is specified with mean 3. M is equal to 3. Out of 1,000 taxi drivers, find approximately the number of the drivers with no accidents in a year, more than 3 accidents in a year. First, we shall construct the probability function corresponding to each driver. Let x denote the number of accidents in a year. Let x denote the number of accidents to a taxi driver in a year. I am going to establish this probability function for each driver. And it is given that m is equal to 3. It is given mean m is equal to 3. Now we can easily construct the probability function. P of x is equal to m power x into e power minus m divided by x factorial. And m is equal to 3. Therefore, this is 3 power x into e power minus 3 divided by x factorial. This is what we call probability function. Probability function with respect to each driver. Here only you can multiply this by 1,000 because there are 1,000 taxi drivers, right? Here only you can multiply both sides by 10,000 and denote left hand side by f of x, or you just find the probability and then multiply by 1,000. First case. Out of 1,000 taxi drivers, find approximately the number of drivers with no accidents. Here x denotes the number of accidents, and there is no accident in a year means x must be 0. Therefore, we calculate P of 0. P of 0. Calculate it. Put x is equal to 0 here and calculate. What is P of 0?
Zero 0.0497.
0.0497. Correct ಇದೆ ಇನ್ನೊಂದು ಚೆಕ್ ಮಾಡಿ. I got it 0.005. Okay, must be correct. Sorry, 0.0497. Since this is the number of taxi drivers, it cannot take a fractional. Sorry, number of accidents, it cannot take a fractional value. Therefore, this can be approximately 0.05, right? This is the probability of not having an accident in a year corresponding to each driver. How many such drivers are there? 1000 drivers are there. Therefore, required is 1000 into 0.05. 1000 into 0.05 is 50. There will be 50 taxi drivers out of these 1000 taxi drivers with no accidents in a year. This is first case. How do you approach this second case? More than 3 accidents. How do you denote that? More than 3 accidents. More than 3 accidents means P, where X is greater than 3. And how do you expand this? P when X is greater than 3. How do you expand it? P of 4, correct? Because 4 is greater than 3. P of 5. P of 6. And it continues. You cannot find this value. P of 4 plus P of 5 plus P of 6, and it goes. Therefore, we use this expression P plus Q is equal to 1. Therefore, P, where X greater than 3, is equal to 1 minus Q. P is equal to 1 minus Q. If X greater than 3 is denoted by P, then what is Q? What is Q? X greater than 3 is P. Then what is Q?
X less than 3.
Less than or equal to 3. X is less than or equal to 3. Therefore, its expansion will be 1 minus P of 0, because 0 is less than 3. It is permissible. P of 1, 1 is less than 3. P of 2, 2 is less than 3. Plus P of 3, 3 is equal to 3. X cannot take values beyond this. Calculate this. Put X is equal to 0. Put X is equal to 1. Put X is equal to 2. Put X is equal to 3.
Zero point 352.
352. Right. And required is, this is with respect to each driver. There are 10,000 drivers. I'm sorry, 1,000 drivers. Therefore, required is 1,000 into this. I got it 0.350, but you got it 0.352. I got it 0.35. If it is 0.35, we get 350 drivers. If it is 0.352, we get 352 drivers. See, I got it 0.35. I got it 0.35. Therefore, required is 1000 into 0.35, which is equal to 350. Next one. communication channel receives independent pulses at the rate of 12 pulses per microsecond. The probability of transmission error is 0.001 for each microsecond. Compute the probabilities of no error during a microsecond, one error per microsecond, at least one error per microsecond, two errors, at most 2 years. 5 cases are there. First statement. A communication channel receives independent pulses at the rate of 12 pulses per microsecond. That means n is equal to 12. Each pulse is an event, therefore n is equal to 12. The probability of transmission error is 0.001. P is equal to 0.001. This is the success now. The probability of transmission error, getting an error, is our success, and its probability is 0.001. Clearly, there are two possibilities. There may be an error in the transmission. There may not be an error in the transmission. Two possibilities are there. When compared to probability of success P, 0.001, 12 is a very large number. Therefore, Poisson distribution is appropriate in this case. Let's define X first. Let X be the number of transmission errors. X denote the number of transmission errors. And we know that mu is equal to m is equal to n into p. We have both n and p substitute. N is equal to 12 and p is equal to 0.001, and its product is 0.012. 12 into 0.001 is 0.012. This is m. Now we can easily construct p of x probability function. Probability function is equal to m power x, that is 0.012 whole power x into e power m is e power minus 0.012 whole divided by x factorial. This will be the probability function. Now let's consider these cases one by one. 5 cases are there. First case, no error during a microsecond. X denote the number of errors. Here no error means x is equal to 0. Put x is equal to 0. What you get here is 0.012 whole power 0. Any finite quantity raised to 0 is 1 into e power minus 0.012 divided by 0 factorial is 1. You just calculate e power minus 0.012.
0.988.
0.988, that must be correct. 0.9880. Next, second case. One error per microsecond, that is P. One error means x is equal to, and x is the number of errors in a microsecond.
Zero point zero one one eight.
0.0118. That must be correct. P when x is equal to 1 is equal to 0.0118. ಎಲ್ಲರಿಗೂ ಬರ್ತಾ ಇದೆಯಾ ವ್ಯಾಲ್ಯೂಸ್? Others?
Yes, sir.
Third one. Third case. At least one error. How do we denote this? At least one error. X greater than or equal to 1. At least one error means 1 is the least value attained by x. X cannot take values which are less than 1. At least one. How do we expand this? This is equal to P of 1 plus P of 2 plus P of 3, and it continues. P of 1 plus P of 2 plus P of 3, and it goes. We cannot find this. Therefore, we use P plus Q is equal to 1. Therefore, P where x greater than or equal to 1 is equal to, if this is P, then what is Q? X greater than or equal to 1 is P, then what is Q?
X
Q
less
is
than or equal to 1.
no, equal to 1 is here. X is less than 1.
1.
Yes. Therefore, this is equal to 1 minus less than 1 means only one possibility, that is 0. 0 is the only number which is less than 1 in this case. Therefore, this is equal to 1 minus P of 0. And what was P of 0? Point, first case, 0.9880, correct? 1 minus P of 0, and in the first case we found P of 0 is equal to 0.9880, and this is equal to 0.012.
0.012.
Yes. This is the third case answer. And in fourth case, what is required? 2 errors. 2 errors mean x is equal to 2. Put x is equal to 2. Calculate. X is equal to 2. What is the answer? Unmute and answer. P of 2.
7.11 into 10 power minus 5.
0.0007. That's right. Next, last, fifth one. At most 2 errors. At most 2 means 2 is the maximum value attained by x. X cannot take values beyond the 2. At most means maximum is 2. Therefore, x is less than or equal to 2. what will be the expansion? P of 0 plus P of 1 plus P of 2. P of 0 plus P of 1 plus P of 2. And we have P of 0. What is P of 0? 0.9880. This was in the first case. Plus P of 1, we just calculate P of 1 plus P of 2. We just found that P of 2 is equal to 0.30 followed by 71. Calculate this.
0.9998.
0.9998. That's right. This is equal to approximately equal to 1. Please make a note of this. This is the probability function and these are the answers. P of 0, P of 1, P when x greater than or equal to 1, P of 2, fifth case, P when x is equal to 0, x is equal to 1, x is equal to 2. Next. A shop has 4 diesel generator sets which it hires every day. The demand for a generator set on an average is a Poisson variate with mean 5/2. It's given that the distribution is a Poisson distribution. The variate is a Poisson variate with mean value, that is m is equal to 5/2 or 2.5. Obtain the probability that on a particular day there was no demand and a demand had to be refused. This is the problem. Let's construct the probability function. To construct probability function, first we have to define what is x. Let x denote the number of demands. Let x denote the number of demands. ನಿಮ್ಮ ಮನೇಲಿ ಗಲಾಟೆ ಇದ್ರೆ
Sir,
mute
chat
ಮಾಡ್ಕೊಳ್ಳಿ.
enable ಮಾಡಿ sir. Sir, chat na enable ಮಾಡಿ.
Wait.
Okay.
Okay, now we can mark your attendance. ನಿಮ್ಮ ಮನೇಲಿ ಗಲಾಟೆ ಇದ್ರೆ ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ನಿಮ್ಮ ಮನೇಲಿ ಏನು ನಡೀತಾ ಇದೆ ಅದೆಲ್ಲ ಕೇಳುವಂಥ ಗೋಲ್ಡನ್ ಆಪರ್ಚುನಿಟೀಸ್ ಯಾರಿಗೂ ಕೊಡಬೇಡಿ. Let x denote the number of demands. Now P of x is given by probability function is given by m power x into e power minus m divided by x factorial. And here m is specified, m is equal to 2.5, 5/2 or 2.5. Therefore, P of x is equal to 2.5 whole power x into e power minus m is e power minus 2.5 divided by x factorial. This is the probability function. Now let's consider first case. X denote the number of demands here. Obtain the probability that on a particular day there was no demand. No demand means x is equal to 0. Put x is equal to 0 and simplify. 2.5 whole power 0 is 1. E power minus 2.5 divided by 0 factorial is 1.
0.082.
Yes, that's correct. 0.082. 0.082. Next, second case. A demand had to be refused.